Welcome back to Physics for All YouTube channel. In today's session, I am going to explain you very important topic in semiconductor unit, that is drift current as well as diffusion current in semiconductor. This topic is very important for the examination point of view, and also some problems will be expected from this topic. Okay, so all of you listen carefully. Without wasting much time, I am going to define about the definition of drift. Okay, in order to give the definition of drift, first of all consider one semiconductor. This is called as a semiconductor. Okay, now without applying any electric field, inside of the semiconductor, the free electrons and holes are moving randomly. Okay, now I am going to apply some electric field capital E to the two sides of the semiconductor. Because of the applied electric field to the two sides of the semiconductor, then what happened? Inside of the semiconductor, which contains positively charged holes and negatively charged free electrons, with the help of the applied electric field, the positive charge of the holes are repelled by the positive supply of the battery and move in this direction. So this is the direction of holes. Similarly, the electrons are having negative charge. These electrons are repelled by the negative supply of the battery, and all electrons are moving in this direction. So in this situation, the electrons and the hole are moving with a particular velocity because of the applied electric field. This velocity is called as drift velocity. It is indicated by V suffix D. So the drift velocity of the charge carrier is directly proportional to the applied electric field. That means if I am going to apply more electric field, the charge carriers will move with more velocity. If I am applying less electric field, they move with the lesser velocity. So because of this reason, I am indicating that the drift velocity of the electrons and holes directly proportional to the applied electric field. Now in this expression, I am removing the proportionality and keeping some constant. That constant is known as mu. So here mu is a constant. This constant is called as mobility. This constant is called as mobility of charge carrier. So this is about the mobility. Now let us consider this is the equation number 1. Now in this equation number 1, Vd is the drift velocity, E is the applied electric field, and mu is the mobility of the charge carrier. That means mobility of the electron as well as the mobility of the hole. Now already we know from the previous discussion, I am going to write equation for the current density. Now I am going to write equation for the current density. So current density can be written as J is equal to Ne into Vd, where N is the number of charge carriers and E is the charge of the charge carrier and Vd is the drift velocity. Now in this equation, I am substituting the equation number 1. Now the current density of the semiconductor can become as Ne into the place of Vd, substituting equation number 1, that is equal to mu into capital E. Now this is I am rewriting once again. So J is equal to Ne into mu E. Let us take this is the equation number 2. Okay, now I am going to apply this expression in terms of the electrons and holes, because semiconductor is a material which contains both electrons and holes. Because of this reason, I am applying this equation number 2 due to the electron current density as well as the hole current density. First I am going to write equation for the electron current density. So I am writing equation for the electron current density. Equation for the electron current density, it can be written using J suffix n, where n indicates electrons. Okay, Jn, this mechanism is called as drift. So Jn drift is equal to same equation number 2. I am written in the form of Ne into mu Ne. Equation number 3. In this equation number 3, small n is the number of free electrons, E is the charge of the electron, and mu n is the mobility of the electron, and E is the applied electric field. Similarly, I am writing expression for the whole current density. Equation for the whole current density is equal to, it can be written as J suffix P. J suffix P, this process is a drift process, so Jp drift is equal to, equation number 2 can be written as Pe mu P into E. In this expression, P is a number of holes and E is a charge of the hole, mu P is a mobility of the hole, and capital E is the applied electric field. Let us consider it is a equation number 4. Now I need total current density inside of that semiconductor because of the drift mechanism. So total current density is equal to, I am writing expression for the total current density is equal to J drift is equal to, I am adding both expressions, that is equal to Jn drift plus Jp drift. Okay, now add equation number 3 and equation number 4. What is the equation number 3? Ne into mu suffix n into E plus, in the equation number 4, what is equation number 4? Pe into mu suffix p into E. Now in that expression, now bring the common terms outside. Now which are the common term here? Yes, so small e is a charge is a common and capital E also common. So I am taking small e and capital A outside. So current density is equal to, bringing E into E as outside. So remaining equation is N into mu N plus P into mu P. This is a equation for the total current density because of drift process. Let us consider equation number 5. Okay, now after writing equation number 5, now what I need? I need expression for the conductivity and expression for the conductivity. So conductivity of the semiconductor. So conductivity can be represented by sigma. Sigma is equal to, definition for the conductivity is the ratio between current density to the applied electric field is called as conductivity. So sigma is equal to J divided by E. Now in this expression from the previous equation we know that what the meaning of J, you can substitute the fifth equation. What is the fifth equation? Now here is the fifth equation. Listen carefully. This is completely equation part. So listen step by step. Otherwise you cannot get the clarity. So now substitute equation number 5. Okay. Now what is equation number 5? So small e into capital E into N mu N plus P into mu P divided by capital E. Here capital E is going to cancel. So what I can write? Sigma is equal to small e into N mu N plus P mu P. This is the expression for the conductivity of the semiconductor because of drift process. During of drift, when electric field is applied to any semiconductor, inside of the semiconductor the free electrons and holes move with a particular velocity. This particular velocity of the charge carriers is known as drift velocity. Because of the drift velocity, the charge carriers move in a particular direction which can get current through the semiconductor. This phenomenon is known as drift current. Okay. Now suppose if the given semiconductor is intrinsic, if the given semiconductor is intrinsic semiconductor, already in the last previous session I am explained that in the case of intrinsic semiconductor always it has equal number of free electrons and holes. Therefore, I am substituting electron number n and hole number p is equal to ni. Now let us consider this is equation number 6. Now I am going to substitute n is equal to p is equal to ni in the sixth equation. What I can get? Sigma intrinsic. Now I need equation for the conductivity of the semiconductor because of drift process. Sigma intrinsic is equal to, in equation number 6, substitute the place of n, substitute Ni into mu n, plus in the case of P also substitute Ni into mu P. In this equation number Ni is common, we can bring outside. So what you can get here? So n suffix I into E remaining is equal to mu n plus mu P. This is a equation for the conductivity due to the drift process. Sigma intrinsic is equal to Nie into mu n plus mu P. In that expression, what is the meaning of Ni? Ni is equal to, what is the meaning of Ni, my dear students? Ni is equal to intrinsic concentration. Ni is equal to intrinsic concentration, and E is equal to charge of the charge carrier. E is equal to charge of the charge carrier, where mu n comma mu p be the mobility. Mu n comma mu p be the mobility of the charge carrier. So this is about the drift. Now we will discuss about the diffusion current. What is the meaning of diffusion current and what is the difference between the drift current, we can discuss in this session. Now to know about the diffusion current in the semiconductor, consider one semiconductor which contains electrons and holes. To know about the definition of diffusion current, consider a p-type semiconductor and n-type semiconductor. Already we know that in p-type semiconductor it contains majority number of holes and minority number of electrons. At the same time, coming to the n-type semiconductor, it contains majority number of electrons and minority number of holes. That is, holes and electrons are unequal in the p-type and n-type semiconductor. Because of this reason, without applying any electric field or without applying any temperature to this semiconductor, here the excess charge carriers are moving from high concentration region to low concentration region. That movement of charge carriers due to the unequal number of charge carriers is known as diffusion of charge carrier. This is a main definition of diffusion current. Now in order to get derivation of diffusion current, now consider it is a n-type semiconductor which contains more number of electrons. Here electrons are less in number. That means as the distance x is going to change from n-type to p-type, the number of electrons also is going to change. That is, the diffusion of charge carrier directly proportional to the concentration gradient. That can be written as dou delta n divided by dou x. In that equation, delta n represents number of electrons. Delta n represents number of electrons diffusing from the n side to p side, and dou x is a distance changes. According to the Fick's law, as the time increases, the rate of flow of electron number is going to decrease from the higher region to lower region. It can be represented by using the minus symbol in the above equation. Therefore, this dou delta n by dou x equation can be written as minus dou delta a into dou x. Now in this expression, now remove the proportionality symbol. I am keeping is equal to minus d into dou delta n by dou x. In that equation number 8, d is a constant. This constant is called as diffusion constant, and delta n is a excess electron concentration in the n region. Now we need equation for the current density due to the diffusion process. Jn diffusion is equal to expression for this is minus into charge of free electron into diffusion coefficient. Now in this equation, so in the place of diffusion coefficient, diffusion gradient, substitute equation number 8, then Jn diffusion is equal to minus into electron charge is E, and again equation number 8 minus Dn dot delta n by dou x. Now here this minus and this minus is going to become plus, therefore Jn diffusion is equal to what we will get, Edn into dot delta n by dou x. This is equation number 9. Now the same equation can be written in terms of the diffusion of holes. So similarly we are writing diffusion of holes from the p type to n type, that can be written as minus dp into dot delta p divided by dou x. Now rewrite equation for the current density due to hole diffusion is equal to charge of the hole into concentration gradient or rate of diffusion. So Jp diffusion is equal to charge of the hole is equal to positive and its magnitude is equal to E, and remaining concentration gradient or rate of diffusion can be written from the above expression, that is minus dp into dou delta p divided by dou x. Now you combine this equation, what you can write, Jp diffusion is equal to minus E dp into dou delta p divided by dou x. It is equation number 10. Now we need to add total current density because of diffusion process can be written by adding Jn diffusion plus Jp diffusion. That means current density due to diffusion of electron and current density due to hole diffusion of electron, that is equal to substitute 9th equation and 10th equation in the above expression. What I will get, J diffusion is equal to, what is the meaning of equation number 9? Coming back to the equation number 9 is Edn into dou delta n by dou x, that is equal to Edn into dou delta n by dou x, then plus Jp diffusion. What is the meaning of Jp diffusion? Substitute equation number 10, that is minus into plus minus Edp into dou delta p divided by dou x. Let us consider this is equation number 11. Now this is a current density due to the diffusion of a charge carrier. If you can write up to this equation number 11, this is called as total equation for the current density because of diffusion process. In some examination, the examiners may also ask like that, what is the equation for the total current in the semiconductor? Then in that situation we have to add both Jn drift plus Jn diffusion as well as Jp drift plus Jp diffusion. You can add total current density due to the electron because of drift and diffusion. Therefore total current density due to electrons is equal to Jn is equal to Jn drift plus Jp diffusion. Jn diffusion. What is the meaning of Jn diffusion? N mu n into capital E plus Jn diffusion means Edn into dou delta n by dou x. Already we derived it in the diffusion process. We derived this equation in the drift process. So combine the two equations, we will get the equation number 12. Similarly, we need to calculate total current density because of holes is equal to Jp is equal to Jp drift plus Jp diffusion. What is the meaning of Jp drift? Pe mu Pe, and what Jp diffusion is equal to Edp dou delta P by dou x. This is the total current in a semiconductor. This is a very important question for the university examination. Okay, thank you for watching this presentation.